Hello everyone, I'm Frank and welcome to episode 16 of Learn How to Sudoku, where we take very easy variant Sudokus, break them down, and try to teach you how to Sudoku. Today's very easy puzzle is called Quadrentropy by Timotab, and here are the rules. Normal Sudoku rules apply, which means place the digits 1 to 9 in every row, column, and box once each. A digit inside a white circle must appear in one of the four cells surrounding that circle. So that's the quad rule set. The quad circle rule set, usually. I think that's what's called. And basically that means, for example, for this quad circle, in the four cells that are surrounding it, there must appear a 1, a 4, and a 5. And around this quad circle, there must be, in one of the four cells around that quad circle, there must be a 1, an 8, and a 9. Similarly with this quad circle must have a 4, a 5, and a 7 in the four cells surrounding that quad circle. And that's how quad circles work. And the last rule is every 2x2 square must contain a low digit, which is 1, 2, or 3, a middle digit, which is 4, 5, and 6, and a high digit, which is 7, 8, and 9. And that's for every 2x2 area. So that includes this one, this one, this one, this one. Even the quads must have one low, one medium number, and one high. And then the last digit can be any of the three, from any of the three sets. And that's usually called the entropy rule set. 2x2 entropy rule set, usually, I think. And that's why this puzzle is called Quadrentropy. I still can't really say it right, but yeah, it's combining the quadruple cell rule, or quadruple circle rule, with the entropy rule, and it's making a puzzle out of it. Anyways, if you'd like to play along, there's going to be a link in the description. And now, let's learn how to Sudoku. Okay. So the one thing that I see in all these quadruple cell rules is that they both share one number. Anytime you have two of them sharing the same number, you know that the number has to be in the cell that's specifically in between them, right? Because there must be a 4 around this cell, so it has to be in one of these 4 cells. But there must be a 4 around this quad cell, which means there must be a 4 around in one of these 4 cells. Well, the only cell that satisfies that's both in these 4 cells and these 4 cells, is the one in between, which makes this a 4. And similarly with these two quad cells, you have a 7 that's shared. So therefore this must be 7. Around these two quad circles, you must have 2. You have a 1 that's shared between them. So this is 1. And between these quad circles, it is a 9. So this must be a 9. And these quad circles share a 1. So therefore this is a 1. In addition, you're given essentially information about the... Okay, so one thing I like to do with the entropy rule set, that's 2x2, is I like to make the highs red, the mediums green, and the lows blue, so that I can see visually what the how the rule set plays out, right? Now the thing is, for this, what we know is that there are going to be 2 lows here because it's 1 and 2, and in this 2x2 we also need a high, and we know it has to be a 7 because 8 and 9 have to be around these two, or sorry, in these 3 cells because of the quad circle rule. So 7 is the only one that's left over to be in these 3 cells. Well, we know this can't be 7, and this can't be, which means because of this cell. So therefore, the 7 has to be one of these two cells. We also know there has to be an 8 and a 9 in one of these two cells. And we know there needs to be a low with those because we have two highs, we have a medium, but we do not have a low yet. Therefore, the last one in this set of three cells must be a 3. So this is 3, 8, and 9. And we know this can't be a 9 because of this 9. So this is specifically 3, 8, and 9 here. This has to be 1, 2, and 7. Therefore, we have a 1, 2, 7 triplet and a 3, 8, 9 triplet in box 1, which eliminates both 1, 2, and 7 and 3, 8, and 9 in the rest of the box, which means we know the other boxes are 5 and 6. So this is 5 and 6, and this is 5 and 6, which are both middle digits, so we can color them green. So we know one of these has to be high and one's low. One of these is high and one of these is low, but this one has to be low specifically, which means this one has to be high. So therefore we know this is an 8 because it cannot be a low, it has to be a high, which means this cannot be 8. We have a 3, 9, 3, 9 pair now here. Let's see. This must have a 4 and a 5 that are in the three remaining surrounding cells, right? That means it has two mediums and one high, so that means it needs a low. Well, there also is a 2 and a 3 that's around these three cells, so this cannot be 2 or 3. What does that mean the last low is? It has to be a 1. So this has to be 1, 4, and 5. Obviously, this can't be 4. This can't be 1. So 1 has to be one of these two. In addition, we know this has two lows, which is 2 and 3, and a high, which is 7. So now we need a middle digit. So this is and what is the last remaining middle digit here in box 3? It's not 4 or 5, it's 6. Therefore, this must be 2, 3, or 6. We know this is a 4 or 5, so therefore this is a middle. We don't know what that is. So what are the remaining digits in box 3? We have a 1, 4, 5 triplet, which eliminates 1, 4, and 5 from the rest of the cells in the box. And we have a 2, 3, 6 triplet, which eliminates 2, 3, and 6 from cells in the rest of the box. Therefore, that leaves 8 and 9. This can no longer be an 8 because of this 8. Therefore, this must be a 9, which makes that an 8. And these are all high numbers. Now, this is a middle number. So we have in this 2 by 2 area, we need a low number. So therefore, this must be a low. So this cannot be 6. This cannot be 9. So this is now 3, and this is 9. That's 3 in the corner. We celebrate. These can no longer be 3. So we now have a 2, 6, 2, 6 pair in. This is low. This is high. We now know this is high. We have a high and two mediums in this 2 by 2 area. Therefore, we need a low here. So this has to be low, which means this cannot be 7. Where can the 7 be in box 1? It can now only be here. So this is a 7. Again, we have a 2, 6, 2, 6 pair in box 3, which eliminates 2 and 6 from the rest of the box. Therefore, this must be a 3. Let's see. We know there's a 1 and a 2 here. Those are two lows. We also have a high in this 2 by 2 area around this quad circle. So that means we must have in the last remaining 3 cells of this 2 by 2 area a middle. Well, 5 and 6 are already taken by these 3 cells. So this cannot be a middle 5, 6 in these 3 cells. What's the last middle digit available? It's a 4. So therefore, this is a 1, a 2, and a 4. And this cannot be 4. Therefore, this must be a low number. This has to be 5, 6, and 9. We have 5 and 6 are two middle numbers. 9 is obviously a high. Therefore, we need one low to go in this 2 by 2 area. And we already have used 1 and 2 in the box. Therefore, what's the last digit that can be a low in these three cells? It has to be 3. So this is 3, 5, and 6. Oops. This is 3, 5, and 6 available here. Which means we have a 3, 5, 6 triplet and a 1, 2, 4 triplet in box 7. And this, we number this, the boxes 1, 2, 3, 4, 5, 6, 7, 8, and 9, because it's this is just usually this is standard that we have because it's Western reading notation. So therefore that makes it just easier for us to have what is it? It makes it easier for people to understand, so that we have these norms in the variant Sudoku community, so that it makes it easier for us to communicate with each other. Anyways, of the remaining cells, we know we do not have a 1, 2, 4 or 3, 5, 6 in the remaining cells in box 7 because of the triplets there. Therefore, this is 7 and 8, and this is 7 or 8. Well, this is 7 specifically, which means this can't be 7. Therefore, this is 8, and therefore this is a 7. And these are all high digits. Now we have, in this 2x2 area, we have 2 highs and a low. That means we need a medium in the last cell. So therefore, this cannot be 3. This is 5 or 6. We have a 5, 6, 5, 6 pair in column 3, which eliminates 5 and 6 from the rest of the column, which means this can't be 5 or 6, so therefore this is a 3, which is a low, which means this can't be 3, so it must be 5 or 6, which is a middle digit. Now in this 2x2 area, we have 2 highs, a middle, and now we must have a low. So this cannot be 4 ever, because this must be low. Therefore, where is the 4 in box 7? It must be here. And this is a middle digit. And now for this one, we have 2 high digits in 7 and 8, right? And we have 1 low digit, so what are we missing? We're missing a middle digit now. Well, the middle digits of 4 and 5 are already taken, and in fact, this 4 means this neither of these can be 4. So where's the 4 in box 9? It has to be surrounding the quad circle, and it can't be these two, so it must be here. So this is a 4, and it's also a middle. This has to be 1, 7, and 8. The 7 and 8 are both high. The 1 is low. We need a middle, and it cannot be 4 or 5, so the last middle possible is a 6. So therefore, this has to be 6 with 7 or 8. This is 1, 4, 5. We have 2 middles in 4 or 5. 1 is a low. We also need a high in this 2x2 area. And we already have used 7 and 8, and this can't be 7. So therefore, where is a 7 in this quad circle? It must be here. So this is a 7, and it's a high. And we need a high in one of these two cells. And it cannot be 7, and it cannot be 8. Well, that means it must be a 9. So this is a 5, 9 pair. Now we have a 5, 9 pair and a 6, 8 pair in box 9. We also have 1, 4, and 7, which means we cannot have those digits in the rest of the cells in the box. That means that leaves only 2 and 3 available. Therefore, this can't be 3 because of the 2 3s that we see here. Therefore, this must be 2, and this must be 3. That 2 means this can't be a 2, so this is 6, this is 2. What else do we have? These are all low. Because of that, in this 2x2 area, we have 2 lows and a middle, so we need a high here, which makes this the 8, because 6 is not high, which makes that a 6, and being a middle digit. In this 2x2 area, we have 2 lows and 1 high, so we still need a middle, so therefore this is a middle, which makes that a 5, and makes that a 9. And therefore this is a high. This can't be 5 anymore, so this must be 4, which means this can't be 4. This can't be 6 because of this 6, therefore this is a 5, which makes that a 6. This can't be 6 because of that 6, therefore this is a 5, and that's a 6. And let's color these. So this is low, this is middle. Since this is low, we have 2 highs and a low already in this 2x2 area. We need a middle, so this is middle, which makes that a 5 and makes that a 1. And this is low. This can no longer be 1, so it must be 2, which makes that a 1, and it also makes that a 1, so that's 2. And let's see. And we'll go in the final box with the quads. This is 1, and it has 4 and 5, which are both 2 middle numbers. So we have 1 low, 2 middle numbers, and now we are missing a high number. Now the 8 and 9 are already surrounding this quad circle, so therefore it cannot be in any of these 3 cells. So what's the last high digit? It's 7. So this must be a 4, 5, and 7 triplet. This has an 8 and a 9 surrounding it, so that's 2 highs, and we have 1 low already. So now we're missing a middle digit. And 4 and 5 have to be surrounding in these 3 cells, which means they are not available here. What's the last middle digit? It's a 6. So therefore, the 6, 8, and 9. We have a 6, 8, 9 triplet and a 4, 5, 7 triplet in box 5. We also have a 1. Therefore, the remaining cells must be a 2 and a 3. And these are all low digits. Okay, so what are the remaining digits in each row and column? This has to be specifically 1, 4, and 7, and this can't be 1. This is 2, 6, and 8, and that's fine. And this must be 3, 5, and 9. And we'll just go through each triplet and then set them, or not set them, get essentially what's left over. So this is 1, 5, and 8. This is 3, 6, and 7. And this is 2, 4, and 9. And you notice all of them contain a low, a medium, and a high number. Doesn't have to be the case normally, but that's fine. This is what? 1, 4, and 9. This has to be 3, 5, and 8. And this is 2, 6, 7. This must be 2, 4, and 8. This is 1. No, it's not 1. It's 3, 6, and 9. And this has to be 1, 5, and 7. Now, the thing is, how do we start solving this? Probably the easiest one is look at the corner 2x2 areas, or the area surrounding that's in the vertexes of the box. The 2x2 area that's surrounding the vertices of the boxes, right? We see 2 low digits. Well, you can only have 2 of the same set in each 2x2 area at most, because you have to have 1 of each set, and if you have 2 already in one set, you have to have 1 of the remaining other sets. So this can never be low, which means this cannot be 3, and this cannot be 2. Similarly, you have this set, right? Also, this 1 means this can't be 1, and this can't be 1, and this can't be 1. But we have 2 low numbers here, which means these cells both cannot be low, because otherwise you would have 3 low digits in a 2x2 area, which eliminates 1 possibility for one of the sets, which breaks the rule. So this cannot be 2, and this cannot be 1. Well, we now have a 4, 9, 4, 9 pair in row 7, which eliminates 4 and 9 from the rest of the cells in that row. So this cannot be 4 and 9, therefore this is a 1, which means this can't be 1, and lo and behold, that makes a 4, 7, 4, 7 pair in row 1, which eliminates 4 and 7 from the rest of the row, which makes that a 1. So now we know this is a low, this is a low, we have a low, we have 2 lows in this 2x2 area, we have a middle, which is the green. Therefore, we cannot have a low and a middle now in the rest of the 2x2 area. It must have a high. So this is a high, which makes that an 8, which means these can no longer be 8. And this can't be 8. So this is low or middle because it's 3 or 5. Well, the problem is either way, if it's low, that's 2 lows there. If it's middle, that's 2 middles there. And what are we missing in this 2x2 area then? We're missing a high no matter what. So therefore, this is a high, which makes this a 9 and makes this a 4 then. So that's a middle. This can no longer be 9. This is also low or middle. But the thing is, this 2x2 area has 2 highs and a low already. So it needs a middle digit from the middle set. So therefore, that's middle, and it's a 5, which makes this a 3, and therefore not a middle, it's a low. Therefore, this can't be 3 because of the possibilities that are there. This is no longer possible to be 3. Makes that a 2 and makes this a 3, which means this can't be 3. This can't be 5 because of this 5. So therefore, this is a 9. This can't be 5 or 9, so therefore this is 3, which makes this low, this high. We now have 2 lows here and a high. We need a middle. So this has to be middle, which means this cannot be 7. Also, these can't be 5 because of the 5. So now you have a 4, 7, 4, 7 pair in box 5, which eliminates 4 and 7 from the rest of the cells in the box. So therefore, this is 5. This can't be 3 or 5, so now it must be 8, which makes this a high. This can't be 3 or 8, so it must be a 5, and that must be a middle digit. We have a 4, 7, 4, 7 pair in column 4. That eliminates 4 and 7 from the rest of the column. This can't be 2 either, therefore this must be a 6, which is a middle digit. Neither of these can be 6. And these can't be 9. So now we have a 6, 8, 6, 8 pair in box 5, which eliminates 6 and 8 from the rest of the cells in the box. Therefore, this is a 9, which makes this a high. In this 2x2 area, we have 2 lows and a high. So therefore, we're missing a middle digit. So this must be middle, which makes that a 4. And this is 7. So that's a high. So now we have 2 highs and a middle in this 2x2 area. We need a low digit. So this must be low, which makes this a 2. So this cannot be a 2 anymore. We have 2 lows and 1 middle in this 2x2 area. So we're missing a high. Therefore, this is a high. And this must be a middle. Therefore, this is 8 and this is 6. So this can't be 8. This can't be 6. And this can't be 6. And this can't be 4 also because of that 4. So this must be a 2, which makes this a low. This can't be a 4 because of that 4. So this is 9 and therefore high, which makes that a 4 and a middle. This can't be 2 or 4 anymore, so it must be 8, which is a high. This can't be 8, so this is 4 and a middle. This 2x2 area has 2 middles and a low, so it's missing a high. So therefore this is high, which makes that a 9. That can't be a 9 anymore. It can't be 6, so it must be 3, and therefore it's a low. This is a middle, and it's 6. We have here in this 2x2 area, this is 2 lows and a high, so we're missing a middle. So this must be a middle, which makes that a 5. That makes that a 7, which is a high. And that makes this a 1, which is a low. This can't be 6 anymore, so it must be a 2, which makes that a 6. This can't be 4 because of that 4, so this must just be a 7. That's a 4. So this must be blue. These are both green. And this is red. This can't be 7 anymore, so this is a 2. This is a 7. This is low then. This is high. This can't be 3 or 6, therefore it must be 7, which is a high. We have 2 highs and a middle in this 2x2 area, so we're missing a low. This is low then. This must be 1. This can't be 8, so it must be 5, and that's a middle. These can't be 6, can be 6 or 7, so this must be 3, which is a low. And now in this 2 by 2 area, we are, well, this has to be a 6, and it's a middle, and therefore this must be high, and that's an 8. And that's how you solve it. A very cool use of the quad cells mixed in with the entropic rule set. Or it's an entropy 2 by 2 rule set. Which is, that's not, I wouldn't say it's that common, but it's not uncommon either. Let's see, yeah. And as you can see from the coloring, there's no 2 by 2 area, or every 2 by 2 area has at least one low, one middle, and one high digit in it. Pretty cool. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.